Good day, everybody, and we are back again together. And this time around to do and look at the IEB exam. I just want to say to all of those candidates who are writing the IEB exam in South Africa, just want to let you know I'm still your plug. And for those of you who are going to be doing the Department of Basic Education, the DBE exam, this would be a good way to kind of revise in a sense. Some portions of this might not be necessarily relevant for the DBE exam, but for those of you, writing the IB exam, I mean, you'd find obviously relevance in this. So, yeah, if you haven't subscribed, please just do the right thing and tell everybody that we are dishing out great lessons here. And for those of you who need assistance with mathematics or physical science, please don't hesitate. Just send us an email, and our email address is info@mlungisinkosi.co.za. All right, so I'm going to start with question 2, okay, which has to do with velocity and time and all of that. Let's get right into it. By the way, I took this from the 2018 exam. So if you can download the question paper so that you can just go through it with me. Right, so it says a toy car is pushed in a northerly direction. So that's very important. They're telling us the direction there along the ground for several seconds, and then it is released, right? So they say the car continues to move until friction brings it to rest. Okay, the velocity versus time graph shown below represents the motion of the toy car. Now, before we go into just answering the question, there are two things that I want you to always be mindful of when you are looking at velocity time graphs. The first one is, well, first of all, under a velocity time graph, the gradient in a velocity time graph should always represent, or will always represent, acceleration. So you can see here that the velocity is actually increasing with time. Probably this is the time when we're pushing it. And another very important thing to note, they told us it was being pushed in the northerly direction. So it means that we've taken north, in this case, as our positive direction. Why? Because I can see my velocity is increasing in the positive direction. So as a result, now at 3.5 seconds, probably this is where they now release the car, and they tell us that the car continues to move until friction brings it to rest. Now think about it. So here it is, we're pushing it, and the velocity increases, right? Once we get to 3.5, we release it, and then what begins to happen? Right, it's moving on its own, but friction is actually taking effect, and in this case it slows it down up until it gets to rest. Okay, right, now I said there were two things that we needed to consider. First of all, it's gradient, so meaning that this is positive acceleration here it is actually decelerating, it's slowing down. Secondly, the displacement, okay, of the car is actually the area underneath the graph. Okay, so we can always calculate the displacement that way. Now let's get to the question. They say define velocity. All right, as you would know by now, I'm very lazy to write all of those things down. Of course, velocity, we say it is the rate of change in position, or we can say it's the rate of change in displacement. Okay, that's velocity. So the second one, 2.1.2, they say calculate the magnitude of the maximum velocity of the car, right? So we want to find out what is that velocity v there, right? So what I'm going to do is let's go into the graph and try to find out what is that velocity. By the way, I just forgot a portion there. They told us that the total distance traveled by the toy car is 17.5 seconds is 29.8 meters. Now, if you remember what I said, we said the area underneath the graph, okay, will always give us the displacement. Okay, so what I can do is, let's find out what is the area. Okay, let's try and calculate that area. And what we can do, you can see there, you've got somewhat two triangles. Okay, or you can just take the entire triangle there. Okay, we'll say half base multiplied by perpendicular height, which is v there, and it would give us the displacement. So let's do that. So it means, in answering 2.1.2, I'm just simply going to say that displacement is going to be the area under the graph. So our area is the area of a triangle. Okay, so this is half base multiplied by perpendicular height, right? So in this case, I'm going to have, what is my base? My base is between 0 and 17.5. So that's going to be 17.5. Okay. Just be careful when you're calculating that base. Suppose we're taking this smaller, this smaller triangle there. In fact, I wanted to go for this one. The base wouldn't be 17.5 because now you're starting at 3.5 and you're ending at 17.5. So you take the difference between the two values. Please keep that in mind, right? Multiplied, all right? So we're taking half base multiplied by perpendicular height, and our height in this case is our speed v. Okay, right? But we know they had told us what is the area, what is the displacement. Okay, the total distance traveled in this case was 29.8. So it means that the area underneath the triangle would also be 29.8. All right, and all that we need to do now is just calculate the speed v. Right, so we're going to divide both sides by a half of 17.5. Okay, so that I cancel that, but of course what I do on the left I also do on the right, or the other way around this time. Okay, so of course that goes away, so velocity, I get a value of 3.4 meters per second. Okay, right, so that's my velocity there. That's how we would get the velocity v. All right, and just please note they said distance there. So but in this particular case, because it was heading in the same direction, the displacement would be the same as the distance that is traveled. Okay, right, let's go to the next question. They say the car has a mass of 20 kilograms. The only forces acting on the car during the last 14 seconds are the weight and the friction, right? Okay, so they are telling us which are the forces that are acting. So let's do this. So we know that the forces that are acting on the car, they said it's the weight of the car. Okay, so there's our weight there, but it's also friction. Now remember, we're heading in the northerly direction. Well, northerly direction. Okay, so what that means, okay, I'm gonna take that direction as my north, if you don't mind. So if that's my northerly direction, in this case, it simply means that the acceleration would be actually in the opposite direction. Remember, it's the frictional force is opposing the motion, so the friction would oppose the motion. Okay, so that would be frictional force. If I'm heading in that direction, friction is opposing, and of course the weight of the car, right? So I'll call it kinetic friction there. Right, now they say to us, calculate the frictional force on the car during the last 14 seconds. So remember, the last 14 seconds are these ones here, from 3.5 to 17.5. That's our 14 seconds, right? So is it possible for us to find out what the acceleration of the car is during those last 14 seconds? Of course, now that we've got the graph, we know what the value of v is. We found it to be 3.4. Now we can find out what that acceleration is. And remember what I said, that when you find the gradient underneath the velocity time graph, that would be the acceleration. So I'm going to say, well, what is our gradient in this case? or you can call it m, whatever it is that you want to call it. Okay, so in fact, let me just show emphatically there I'm answering 2.1.3. So the gradient is going to be the change in velocity divided by the change in time. Okay, so let's find out. So in this case, I'm going to take that as part of my value. So that's going to be v, which is 3.5. Okay, sorry, that's 3.5 in terms of time, and the velocity is v. And I'm going to take that time there at 17.5, and my speed is 0. So I'm going to say, well, let's say 3.5, sorry, not 3.5, rather 3.4, which is our speed, change in velocity. 3.4 minus the velocity at this point, which is 0, divided by, when the velocity was 3.4 here, the time was 3.5, and when the time, well, I mean when the velocity was 0 at that point there, the time was 17.5. Okay, that's our 14 seconds. Okay, so let's quickly calculate that. So I get an acceleration of negative 0.24. So we're going to keep our answers to 2 decimal places. So meters per second, of course, that's normally what we are instructed under IEB. So our acceleration in this case, in fact, let me not write G there, let me write acceleration A. So our acceleration rather is negative 0.24 meters per second squared. Now, remember what you want to find is the frictional force, right? So if you think about the direction of its acceleration, so if we took the direction, the northerly direction, remember we've assumed that that's our north, right? Okay, so if we took the northerly direction as our positive, it simply means that obviously the southerly direction should be our negative, right? So it simply says to us that our car in the last 14 seconds is accelerating in the southerly direction. So now we need to find the force, the frictional force. Now going to say, well, F net, this is equal to MA, right? But what are the forces that are acting in that particular direction? Of course, we're not looking at the weight of the car, all right, because that's a force that is perpendicular, okay, to our motion. So in this case, we're going to only take sum of forces in the horizontal direction, right? So if we look at that, what are going to be the forces? It's going to be the frictional force only. And remember, that's the reason why it was actually slowing down in the first place. So it means that frictional force, okay, would be equal to the mass multiplied by the acceleration. We know what the mass is. They said it's 20 kilograms, and the acceleration was minus 0.24, okay? And obviously then it means that we're going to just multiply there. So 20 times 0.24, and we simply get a value of 4.8. So means that our frictional force was negative 4.8 newtons. Now you keep in mind, why are we getting a negative value? Because it's telling us that friction is actually opposing the motion. All right, so I hope that's been clear enough for you. Okay, yeah, let's go to the very next question. Right, I'm just going to bring this over to this side, and we will continue over the other side. So they say in 1997 a high-speed car broke the world record, the world land speed record rather. They say the car accelerated uniformly in 2 stages as shown by the information provided in the table. Right, they say the car started from rest. All right, so we can see there are 2 stages that are given there. So stage 1, the car started between 0 and 4 seconds. Okay, the speed at the end was 44. And stage 2, which is from 4 seconds to 12, the speed at the end there was 280. So we're going to look at this as 2 stages, right? So we set the time there. This is between 0 and 4 seconds. And this is between 4 seconds and 12 seconds, right? I know the picture doesn't actually match. In fact, maybe let me write that 4 seconds there so that you can actually see that there's a greater length of time between the two. Okay, so let's take that there. So this is 0 to 4 seconds. This is 4 to 12 seconds, right? Now, I know we started from rest, okay, at 0. So this is our velocity. So we started at 0 here. And at the end of the first stage, meaning at 4 seconds, we were at 44 meters per second, right? So at the beginning of the second stage, which is between that 4 seconds there and 12 seconds, the maximum speed there was 280. Okay, now first thing that they ask us to do, they say to us, calculate the average acceleration during stage 1. Okay, so we want to know what is the average acceleration. So remember, acceleration is the change in velocity divided by change in time. So we can say, well, it's velocity 2 minus velocity 1 divided by time 2 minus time 1. Now, please always be careful when you are substituting there, that in the same way that you take velocity, that you keep the same order when you take the time, right? So we'll take that 44 as our second and 0 as our first one. Okay, remember they're talking about the first stage, divided by when the velocity was 44, time was 4, right? And when the velocity was 0, time was also 0. So as we continue, so we know that it's going to be 11, okay, meters per second squared. All right, so that's our acceleration. Oh, that's an incredible acceleration. Okay, so let's go to the next stage. Now they say to us, calculate the total distance traveled by the car in 12 seconds. Okay, so now we're looking for the total distance. All right, so it means that we now need to look at the second stage, and keep in mind that those they told us that it's accelerating uniformly in 2 stages. So in this case, the acceleration there should be somewhat different to the first one. So for the first stage, okay, so I'm going to break this down into 2 stages. So 2.2.2, remember that was 2.2.1. Okay, so I'm going to break it down in 2 stages. Let's find out the distance. Let's call it S1, right? Stage 1. Okay, so I'm going to say, well, I've already have the acceleration. I've got the time that it took. Okay, that would be 4 seconds. And I also have the initial and final velocity, right? So which equation can I take? Well, I can simply say, well, v squared is equal to u squared plus 2as. Okay, so I'm looking for the distance there. So in this case, this would be s is equals to v squared minus u squared over 2a. All right, so my final velocity was 44. Okay, my initial velocity, so that's 44 squared minus initial velocity, that was 0 squared divided by 2 times a, which was 11. And by the way, you could have used the third equation as well. Okay, s is equals to ut plus half at squared, right? You could have used that. And let's find that distance s1 there. Okay, but whilst we are at it, why don't we do the same for S2? We'll come back to the actual answers. Why don't we do the same for S2? So this is when it was accelerating again, but this time around, remember, we don't have the acceleration. So I'm going to actually take an equation that does not have acceleration. So I'm going to take the fourth one. S is equals to U plus V over 2 multiplied by T, right? Multiplied by the time that it took. So in this case, my initial velocity, now remember, at stage 2, I'm starting at 44, and my final velocity is 280. So initial is 44 plus 280, okay? And I am now going to divide that by 2 and multiply it by the time. Now the time is between 4 and 12 seconds. So in this case, our time is going to be 8 seconds. Now, we can find our answers there. Okay, let's do that quickly. So for the first one, I get a time, rather a distance of 88 meters. Okay, and for the second one, I get 1,000. Okay, let's create some space there. I get 1,296. Whoa, that's incredible. That's an incredible distance. So that would be our distance. Now remember, what did they want? They wanted the total distance. So obviously it means that our total distance should be equal to the sum of the two. Okay, so I'm going to take S1 plus S2, and in this case that gives us 88 meters plus 1,296, and that should give us 1,384 meters. All right, and we would have gotten ourselves a full 21 marks, right? Yeah, so that would have been 21 marks altogether. Right, so I hope that you were able to follow on in that question. I hope that I answered it in a way that you were able to understand. All right, so we'll continue doing this for those IEB questions. All right, hopefully it will be assisting you as you prepare towards your exams. Otherwise, ladies and gents, I'll see you guys next time. Sharp, sharp.